Good morning, everybody. We have already more than 16 participants. We are going to wait another minute to see if some others are joining. And then we will kick off. Just before we then officially kick off, I hope you can hear us. Maybe a little sign from somebody from our audience. Good. Wow. Good. Good. Then I think we are going to kick it off. I'm pretty sure during the next couple of seconds and minutes, some other people will join. First of all, welcome everybody to this deep dive session today called Enhanced RAG. Apparently, this is a topic which raised some interest, and we are keen to share some more details today. And I'm pretty sure you are eager to learn more as well. I want to also welcome my colleagues, Vlad, which you already might know from the AI tour so well, Andreas and Marius, our key team, core team on this specific topic. They will also take over after my introduction and then walk you through this interesting topic. Now, before we start with the content, 2-3 organizational topic, the session will be recorded. The session will be held in English. If you have a question, we want to keep this a little bit interactive and also a dialogue. So please raise your hand if you have a question, and then we will definitely then try to ask you specific questions during the session and not at the end. We will stay tuned for the next 57 minutes, and you will receive after this session an email, a thank you mail, with also access to the slides and also to this actual recording of this session. Just for information, so you do not need to take some screenshots or whatever. You will receive the information, of course, but feel free to make some nice screenshots while Vlad and my team is talking. Pretty sure they look nice. Good, then let's kick off. We go, and as an introduction on the next slides, Marius, who is walking us through and sharing his screen. Let me do a short recap. First of all, last week, Marius, on the next slide, please. Last week, for those who attended the Microsoft AI Tour, we offered you this deep dive session today, where we want to, in more detail, explain what is the enhanced RAG, which we created at Capcom by our engineering team, and also a little bit the difference on an architectural, but also with some live demo, with some live results, so it becomes tangible. As you know, we here in Switzerland try to also do hands-on experience and not only some slides. That's why we try to keep this session also very interactive. So today, what is the difference, again, about our enhanced RAG and the traditional RAG industry standards comparison, live demo comparison, and if you have questions to understand better the architecture and what happens in the background, again, please raise your hand. We will give you the room for discussion. Thanks, everybody, for joining. I wish you now the next 50 minutes fantastic session. I will try to orchestrate as best as possible, and I hand over to my colleague.
Thank you, Nello. Hi, everyone. Thank you so much for the interest. Just today's session will be more technical session. I just want to warn you. We're gonna, and I guess that's why you're here. We're gonna do a more deep dive into the architecture and concepts behind the enhanced RAG. And what we're gonna also do is actually compare two solutions. One is with enhanced RAG, and the other solution that you all know, it's Microsoft Copilot. And just to demonstrate what we actually talked about on the Microsoft AI tour that I hoped you really liked, because for me, it was a quite nice event. I also learned a lot. And during our session, just as a very, very short recap, we compare the traditional RAG that Microsoft introduced, supported by Azure AI search service, and we compared it, or let's say we challenged it a bit with this enhanced RAG that takes a bit of a different concept. And as a reminder, what we've done, we've replaced the vector search with a pipeline of mini LLM calls to actually identify the right content. And we also talked about different use cases and applicability of traditional RAG versus enhanced RAG, where traditional RAG sufficient for advanced search type of use cases where you're locating information that is clearly explained in the document. And then enhanced RAG actually goes step beyond and allows you to ask questions that are not directly explained, like research type of questions, use case type of questions, like us humans we like to ask instead of just, give me a number. And also what we talked about is giving complete answers. So give me all legal matters that are mentioned in the document, where vector search type of RAG actually just gives you a subset because of the ranking and similarity search features. So if we go, Marius, forward. So we will now do an architectural dive. So Marius will explain you our pipeline, and we structured the pipeline into the ingestion pipeline and retrieval pipeline, and both are very important in our enhanced RAG approach. And it took us 6 months to fine tune this so that it works. And when I say works, it's not just that we can make a demo, but it is a scalable solution. And we will show you later, because we prepared an agent with tons of financial reports, and we're going to be asking some questions, and we've done the same with Copilot. So Marius, do you want to walk us through the architecture behind the enhanced RAG and the pipeline for both ingestion and retrieval steps? Thank you.
Thank you, Vlad. Sorry. So yeah, as Vlad said, we have the ingestion part and the retrieval part. The one part is the part where we take documents, which you see on the left. We load up a document into storage. Then we read the document, chunk it, put it into chunks, and then there comes the extra step that we do that in the traditional RAG isn't implemented, or you don't do. We create metadata based on different levels. For example, we have one on the document level and one on the page level, and this then runs all in parallel. So we have one metadata for the document, and for each page we have a little metadata that we create based on the content of the page, and then we ingest it into a vector database. So this is the standard step. As you see, we have this red dotted box, which is stuff that we changed or added in comparison to the standard RAG. Right? So this whole metadata creation is actually not in the standard RAG. And then when all the documents are ingested, we come to the retrieval part.
And maybe Marius, I will just jump in here.
Yeah, sure.
One tip when we create the metadata, and the reason why we need metadata, one is, of course, and we actually call it compressed content. So we compress the content on a document level, and we compress the content actually for each chunk. And the reason why we're doing that is twofold. One is to be able to identify the right information when we perform a search during the retrieval pipeline. But the other important feature functionality of this metadata is to actually compress the content. Why are we compressing the content? Because when we do a search, we're actually applying a lot of LLM mini calls, and for performance and also cost reasons, we actually create this metadata and search against it. So what we do when we create metadata and when we compress this content, we are actually squeezing out all the descriptive, qualitative, even quantitative content. We only keep the context and the essence, or let's say the pure description on what this content is about. And just to tell you the ratio, it's usually 1 to 5. So from the full content, we are coming to a, let's say, compressed content that is 5 times smaller than the original content, which is a great saving. It makes the whole search much faster and more performant, but also more cost efficient, still keeping the ability to find the right content. Sorry, Marius.
Morris, thank you for the additional details. Yeah, so starting at the retrieval point. So as Vlad said, we now use this metadata to first identify the right document. So if we have 10 documents uploaded, we check all the metadata and check which document fits the most to the question of the user. And then we take this document and do a similar process on the pages using the compressed content, as Vlad explained, and identify the right pages based off of that. And then we just take all the pages that are relevant, or that we identified as relevant, and put them into one final call, which then will create the answer based on the question of the user and the content. And as you see here, we also have here this red box. So this whole identifying of the page separately from identifying of the document is not the case in standard reg. So we mostly replaced the vector search, which you would use in a standard reg, with this solution, because it's just much more detailed. And as I explained, it can cover multiple, or can cover data which is spread over the document, and not just a simple similarity search.
And maybe mentioning there, we also apply ranking of the contents on when we do the LLM search. And here we, like vector search would do, we also provide like a hit ratio, and based on that we also sort the content. But what we've realized compared to vector search is vector search gives you a number, from 0 to 1. Their LLM search, it's quite, how should I select it? The content is very relevant or is irrelevant. There is not much in between, which is really good, and makes the cutoff of the content where actually you want to stop serving the pages or the chunks back into the answer kind of step easier, and let's say with better quality of the content that you're collecting. So just a small detail. We also, Marius, right, when we serve the content back to the user using this LLM call at the end, we also include some metadata. That's also important, because just including chunks or pages without giving metadata context is not always good. And we will show you the example a bit later, because there might be pieces of information like a cost-income ratio that is explained on page 10, on page 40, and on page 60. But page 10 might relate to UBS asset management, page 20 might relate to UBS investment bank, and whatever, the page 30 relates to some other entity of UBS. And if you just look at the chunks, actually it will give you wrong answers, and that's exactly what Copilot is going to do. we will show you later. So it's important to also keep that metadata attached to the chunk when serving the content back, so that the right context is also kept, and that the chatbot is actually not hallucinating, as people would like to say. So that's another important detail that we also figure out makes a huge difference. Sorry, Marius.
And maybe Marius and Vlad, Copilot is just one example, and it's not about Copilot per se.
Exactly.
It's more one which represents the industry standard today. Not that it's going to be a battle between Copilot and Enhanced Rec. Just want to clarify that. But we had to use something which represents an industry standard and just took the Copilot just as a additional note.
Exactly.
Sorry.
I hope there are no Microsoft people on the call because they're going to shoot me. But as Nella rightly said, we are not trying to say Copilot is a bad product. Copilot has its own use, but there are limitations behind this architecture and technology as of today. And I think it's important to understand those limitations when building those chatbots, because we've seen in practice a lot of angry users and a lot of questions. So if you understand upfront what are the challenges, helps you a lot. Sorry, thank you. And Marius, maybe just for the audience, right? There was one of the questions, which models we used. I mean, our pipeline that we're going to demo works on Azure, and for the search and where we use the mini models, we use the 4.0 mini that actually works quite well in identifying the data and kind of selecting the data, classifying the data. It's very fast, it's very cheap. It's 10 times cheaper than 4.0. And then in the last step where we actually serve the answer, where we kind of put the relevant content with metadata and we push it to the user, we use a bigger model 4.0. And in terms of costs, we compare the costs. They're very comparable. Reason being is that yes, LLM mini calls are a bit more expensive than vector search, but on the end, when you use the bigger model, which is 10 times more expensive, you're actually squeezing in less content, which makes the final call cheaper. So net, it's very comparable. And the other thing is, because we can really pick, let's say, the right content and push it into the big model for the final answer, the quality of answers is also better. Florian from Microsoft mentioned on the Microsoft AI Tour, if you put too much information in the contextual window of a model like 4.0, there is something called lost in the middle. That model simply gives priority to the content at the beginning and the end, but the middle is kind of sometimes lost. so you have to be careful about it as well. Marius, thank you.
Yeah, thank you for the additional details. Yeah, so as Vlad mentioned, it's at the moment we use Azure, but as you see, it's also deployable to any other major cloud provider. So it's just the models will differ, but the technology itself or the pipeline or the workflow is deployable to any other of the major cloud providers. Right. And so I think that's it for the architecture. So I think I will hand over to Andreas, if I'm not mistaken, to go into this deep dive, or is it Vlad?
No,
let's do the demo first.
Let's do the demo.
That's good.
Where are the statistics? Sorry. What happened to that slide?
Oh, no.
Okay, doesn't matter.
Maybe it's the next one. Let me. So no.
No. Okay, doesn't matter.
Good. So we will come to the demo. Good. So Vlad, do you want to walk us through the case, and I will just.
No, Marius, I will let you sweat. I will just introduce the topic, and then we can do it together.
Yeah.
So what you're going to see here, and again, there's nothing. We are not trying to make Copilot look bad. Copilot, like many chatbots, is using traditional RAG, It improved lately. We've been testing Copilot also extensively because of some clients that want to use Copilot, and Copilot Reg improved in line with what OpenAI offers, but still has certain deficiencies of what we discussed. And it's definitely a product that can be used for a variety of use cases, but there are also limitations that we talked about and we're going to demo here. And on the left side, I don't know if you're familiar, this is a Copilot environment. What we built just for this demo is an agent using Copilot Studio, where we preloaded a number of financial reports of companies like UBS, HSBC, and so on. And on the right side, you see our enhanced reg. It's just internal UI, but in the background we have the pipeline doing the job as Marius explained. And we're going to take some questions and we're going to just ask the same question in both agents and compare the answers. And then we're going to also go into document to analyze what happened. And we will show the actual document actually during the demo. We don't have to show it now. So, but the quarterly reports, as I've talked about during the Microsoft AI tour, we took this on purpose because in financial industry, this is what we see usually. And second, those reports are very complicated. That there are many challenges with those documents, from how the data is being structured, many tables, a lot of data that is very similar but contextually different, and so on. So there are many ways that chatbot can fail. So Marius, do we want to start with the first question, and we're gonna actually explain what's going on and why we are getting those answers?
Yes. So yeah, as I said, we have both the same setup of the same documents. On one side, our enhanced reg, which you can see on the right, and on the left, we have the Copilot. So I just pasted this question.
And just you have also the document ready, right, Marius, so that we
can preload this.
I mean, the answers are pretty clear. I will let maybe a second for people to read, and maybe we can just show it in a document, but you can clearly see that Copilot didn't identify that piece of information in the report. With enhanced reg, actually, it says that as of specific date, UBS's exposure to emerging market countries was less than 10% out of its total country exposure. And you can see in our reg, you can also see the page. So Marius, do you want to just open it very briefly and we show it to people? So it's a very small sentence, and it's actually related to a risk, as you can see, as country risk, and it talks about 10% of total exposure as of specific date. So this is one detail, and what we've seen with our clients, yeah, quite important answer, and would be a deal breaker if Copilot would say we don't find information. So let's go with the second example. So this is example of, sorry, if you remember from the AA tour, we classified examples or the questions like a search type of questions like this one. And we also classified more research type of questions, so where the content is not directly explained. So this was the search type of questions. So enhanced reg works even better with the search type of questions, which where actually traditional reg should work well. So the second question Mario is asking is an interesting one. And why we picked this question is it's actually very straightforward. What is UBS's strategy for investment banking division in coming years? And as you can see what Copilot did on the left side, it started mixing up things. I mean, when you look at it, the first thing, well, it gave some answer, but it's not talking about investment banking division. It's talking about UBS. And on the right side, you can see a clear answer. What is the UBS strategy for its investment banking division? and it gives information. We're going to see it in the document as well in a second, but talking about what UBS is actually trying to do with its own division. Maybe Marius, you want to show some details around that. No, we need to go to the other pages, maybe page 628. No, we need to read through the content, but it's summary here. You can, because I don't see the answer, maybe you can just search for the number that we have in our answer, sorry. 15. You can search for 15% that it gave. It's easier to find. Otherwise, we're going to search till tomorrow. Yes,
yeah, but
exactly.
we can search, yeah.
Yeah, exactly. So this is the table on the investment bank and the results and yeah, it derived an answer from the financial figures. So let's go with the next question. Yeah, again, we're picking investment bank because it's a division in the financial report. The financial report of UBS talks about financial results of every division. And one typical question would be, right, yeah, so tell me, what is the cost income ratio of UBS investment bank? And look how those two answers are different. So Copilot says you'd identify the right document, and it says that the UBS investment bank cost income ratio is 67%. Our solution says that for the fourth quarter of 2024, it was 80.3%. So let's check the answers and again, I would just search for cost income ratio. There are many tables. Yeah, exactly.
So let me should be here.
Is this investment bank?
Here we have the one cost income ratio.
Because I cannot see it's a smaller window if this is talking about investment bank or those are the group results.
I think so, yeah. Because
Exactly.
there's no, yeah, it's not mentioned that it is investment bank.
So just search for cost income ratio in the document because it's mentioned many times, and I want to show that the one for the investment bank.
So we have it one time here, for example. But this is not for investment bank.
So just take the cost income ratio, Marius, and search it in a document till
yeah,
we find investment bank.
oh wait, I can do this, I think, but I'm not sure if this works in the pop-up window. It's actually working. Never mind.
Excellent.
Sorry.
Maybe we can do that in the background. Maybe Andreas, you can find it, and then we can show it so we don't waste time. But I want to go back to this number and verify if it's correct. It's sometimes hard to find it in a document. Let's move with the next question.
Sure.
So another, question that is very specific. How much did UBS achieve in total gross cost savings by end of 2024? And we are getting very different answers. On the left side, you can see it said that UBS achieved 3.4 billions, and in the enhanced reg, you're getting 7.5 billion. So let's try open the document and show the result. Exactly this here, it's easier because, and now, yes, exactly in the middle. There you go. So in the fourth quarter of 2024, additional gross cost savings, but the cumulative gross cost savings at the end of 2024 amounted to 7.5 billion. And compared to 2022, and that's combined cost base of UBS and Credit Suisse. So if you look on the left side, it says that, UBS achieved a total of 3.4 billion in gross cost savings. And if you look at our answer, it gives a very concrete response without actually adding some unnecessary information around it. So let's go with the next question. And I think this is the last one. So exactly here, actually, this is not a great example, but we will explain it. So we ask what is the net profit growth rate for 2024 compared to 2023, and so what the enhanced reg did, it actually picked the values from 2023, picked the values from 2024, and tried to actually calculate the net profit growth rate. But it picked the right values for 2023 and 2024. If you see on the left side, I don't even understand what Copilot tried to say. And the numbers do not match at all. And we can double check in the reference documents, what is the net profit attributable to shareholders in 2023 and 2024, and actually verify those numbers. And just confirm that they're correct. So we need to look at the table, Marius, if you close it. No, you're opening the same page.
No, it's all different ones. Here we have a table.
Yeah, exactly. So underlying net profit loss attributable to shareholders, as of 2024 and 2023. So 6609 and 2753, if you see the line item in the middle, and that's what he picked up correctly, and try to calculate the net profit. But that's part of the question, and you can just see how incorrect results can be given if you have the underlying information that is not accurate, then the whole answer gets messed up. And if I read the answer in the Copilot, I have troubles understanding what is the answer. So Andreas, you sent a picture. Sorry.
I actually also found regarding to circle back to the other question.
Yes, let's go back to the other question.
It was this one, right? The cost income ratio. And we have it actually was on the page 28. If here investment bank, and then we have the cost income ratio down here.
80.3, exactly.
A bit bigger, yeah.
And just look what Copilot came back with. It said 67%. And maybe just to close, why did Copilot say 67%? Because it picked a wrong cost income ratio from a wrong division. I think probably he picked one from the UBS group or maybe UBS Asset Management, and the reason being is that when they chunk the documents, they don't use this metadata to keep the contextual meaning of that chunk or page, and it's very easy to actually pick the wrong numbers because you're referring to another, let's say, division of UBS. Good. So let's just move on and leave some space for Q&A. Yeah, we will just very briefly talk about couple of deployed agents and some of the use cases that we've used this enhanced reg for. So Andreas will just walk us through that. Thank you, Andreas.
Yeah, I'm sorry, guys. Just one stupid question from my side. We have the statistics now. Should we show them too before we dive deep into the deployed agents we did so far at Capco?
Yeah, let's quickly show the the stats based on the examples which Vlad and Mario showed before. Quickly, Andreas. Before.
Yeah, sure.
You just. Andreas?
Yeah, I'm here.
Okay. No, yeah, you're sharing the wrong screen.
Yeah, sorry, my notebook is not working so good.
But anyway, till Andreas is preparing the slide,
Yep.
it just what we've compared, and we showed this during the Microsoft AI tour. We did 60 questions, 30 standard, and 30 research type of questions. And what we've seen that enhanced reg, as we've shown as well, also beats, sorry, the enhanced reg beats a traditional reg, for example, like Copilot, when asking standard questions, which tap into advanced search use case. And it also beats, or let's say, does better when it comes to research type of questions that are relevant for financial industry. And the differences are not subtle, they're actually quite significant. And what I find also interesting is on the right side, if you see research type of questions, as I said, those research questions are sometimes not very clear, because we've seen users asking questions like strengths and weaknesses on a specific company, and it's hard to vet whether the answer is really good or not. There are many opinions, and that's why we have this partially correct part, and we had our financial experts actually vetting the answers. We had humans really vetting the answers, and what we saw that in the partially correct area, in this case, Copilot actually had a lot of problems. No answers are ideal in kind of this case or for those use cases, but from the human perspective, in terms of the correctness of answers, enhanced reg also did considerably better. Good. Let's talk about how we apply this in production with real use case.
Yeah, let me take over. Now, not to do too much sales and marketing, I had to promise to Nello and Vlad to only use 2 slides. Actually, it's 3, but only with this really small architecture picture of our approach. So what Vlad showed us and Marius, what they showed us is our so-called financial reporting agent. Just but one example of our agents using enhanced reg solutions we deployed on existing client cloud infrastructure. Now, what this agent does in essence is it analyzes and structures massive financial data sets. In this case, you saw the UBS Really report, and the value it provides is, of course, clarity and accuracy when it comes to queries regarding these kinds of documents. Another great example is our so-called operational manual agent. One of our clients provided his clients with a really complex and complicated software on specific questions. Just reading the software manual wasn't enough to provide clarity needed on these specific questions. We use the software manual of the software as well as metadata definitions of code snippets and produce this or build this operational manual agent, which of course was then able to answer very specific questions about how to use this specific software. And of course, this approach is not only applicable to other software, but also to machinery and in general to other systems. An agent I am personally really thankful for is the internal policy agent. Using the information of this agent, I am able to, well, to be compliant to our internal policies. As an example, how do I book my time weekly? This is a really big problem for me. I always forget it. Or another example is how do I approach Nello about a specific approval for a travel? A third agent, which is, in my opinion, really interesting because it really dives deep into the client's processes, is our so-called IKYC agent. And if we take a closer look at the Know Your Customer process, it really consists of 5 big chunks. The first one, customer data collection and identity capture. Second, document verification and validation. Customer risk profile and segmentation, transaction monitoring, and the last one, KYC, data management and record keeping. What our KYC agent is able to do, it automates basically every of these 5 sub-processes of the Know Your Customer process, really enhancing and increasing efficiency and effectiveness of our client. And I think these 3 are really good examples of how we are able to enhance efficiency and effectiveness of our clients.
Maybe just to add to what Andreas is saying, I personally would never deploy financial reporting agent based on Copilot. This will not work. And just to why we pick those cases is that when we did solutions using traditional vector search, we like financial reporting agent, and there are variations to that. Can be private equity reporting agent. We were failing, and the clients were not happy, and that's what pushed us actually to come to something, let's say, more innovative. Also regarding internal policy agent, I'm sure every company, and you probably work in a company that has one internal policy agent, but what we've also seen that people started asking use case type of questions. Not like what is my whatever limit to go out with a client, but they would say explain a story, and they would expect an actually agent or a chatbot to come back with a meaningful answer. So this is very enhanced, right? Actually helped bring those chatbots to the next level of actually interaction with a user or human being. Thanks, Andreas.
So I assume there are no specific further questions. Otherwise, it's now the time also to speak up. David, you have a question. Let me see if we can hear you. No.
Yeah, can you hear me?
Yes, now we can.
Hi, great,
David,
thank
yes,
you.
please.
I have 3 questions.
Yes.
I will ask them in order of priority for myself. First of all, I'm curious about how you define the metadata that you apply to each page. Is there some sort of engineering and analysis that goes into defining what's meaningful metadata? Second of all, I'm curious about your view about other architectures. There's been some talk about things like graph RAG and graph databases. I can see how they may not apply for this kind of data, but I'm curious how you see that fitting into the RAG landscape in general. And then maybe you can say one or two things about what the limitations are of these agents and what you're working on at the moment to enhance them, or what's the sort of next step in this kind of work. Thank you.
David,
Sure.
you nailed the questions. May I ask, what is your role in your organization? Just out of curiosity.
I'm AI product director for similar kinds of agents, but we're at a very early stage of building these things. So
No,
these
it's
are quite
got it.
burning questions for myself.
Yes, yes. Okay, so let's start with the first one. So, so during the ingestion pipeline, Marius will just share the architecture slide. So during the ingestion pipeline, we create the metadata, as you rightfully said, and what we do is actually, yeah, exactly. We are using LLM to actually create that metadata for us, and it's a specific prompt that we design for that purpose. And what's important, and you as a product manager, so this pipeline uses LLM a lot. So on the ingestion to create the metadata, and also on the retrieval to search for the right content, and then serve the right content. And what we do, all those prompts are actually fine-tuned for every use case. And your question is very good because, for example, when we squeeze and derive that metadata, we will have a bit of a slightly different prompt for financial reporting agent than for the, let's say, internal policy agent. And why is that? Because we want to make sure that we capture, or let's say, derive contextually most relevant metadata for that use case. And in case of financial reporting agent, it talks a lot about financial terms, financial information. We built a specific prompt that actually derives the metadata that we were satisfactory with, and it still doesn't lose the context of the information. And what we specifically did, we just said, cut out all the qualitative and quantitative information, just keep the core context, what is being described from the financial perspective in this chunk and on the level of a document. And that's how we derived it. But the important thing is that those prompts are then fine-tuned for every use case. We saw it's not really possible, or let's say for every chatbot, it's not really possible to have one universal pipeline that works just perfect for every case. What was the second question?
The second question, I was just curious about your view on other kinds of architectures like graph databases, and if you're exploring those, the use cases might be quite different.
Exactly. We tried GraphRag, and for this use case, we didn't find it appropriate for various reasons. The GraphRag actually did chug the content, and we could connect contextually the content to a certain degree, but the quality of answers would not satisfactory. And the reason being is again going back to this research type of questions where end users is expecting sometimes opinion or the analysis of the data with the help of LLM based on the let's say on the underlying chunked information. Now, and the GraphRag, what we've seen works very well in the industry like medical industry, where you have very concrete answer to your question. It's kind of like encyclopedia or a huge database of information where you need very precise answer to. But for the kind of agents where you're asking those research type of questions, use case type of questions, this technology didn't work for us. And I have to ask for the third question. I should have written it.
Yeah, thank you. That's very enlightening.
Limitations.
Yeah.
Limitation. So when we started with this approach, we had huge limitations in terms of performance. It was taking, I think the first results we had were like we were waiting 10 seconds for an answer. which was not acceptable. And we managed to solve that by parallelizing those LLM mini calls when doing the searches. Still, it can happen that LLM-based search is slower than the vector search, but that we're talking about magnitude maybe over a second or two, but you're getting a better answer. And I think that's a good trade-off. You've seen also Copilot struggles to provide answers in some more reasonable time, actually took longer. So speed is not always great compared to vector search, but we find it acceptable. It's a matter of second or two difference. Then we had also issues with costs. Initially, our pipeline was searching the content against the full content, and that was just too expensive. And we've compressed the content, and that also squeezed the costs significantly. Nevertheless, cost of every query is a bit more expensive in general than vector search, but we're really talking about very small amounts of 0.0 whatever US dollars per question, so still acceptable. Where vector search still works well, I think, compared to enhanced RAG, is if you just need an advanced search chatbot where you're actually just asking very specific questions that are clearly explained in the underlying document. And if you have this more simple use case, I would go with traditional RAG. It's just out of the box. You have Azure AI Search, as Microsoft talked about. It's very easy to implement. If you use LangChain, which I don't like, it's 3 lines of code, and it works quite well. So if you have like a sales bot where you have a chat agent that supports a salesperson, and you need to understand what are the terms of a specific product, what are the tariffs, or what is the cost of a specific product, I think traditional RAG will work quite okay. But for more complex use cases you've seen, for example, like this financial research agent, a traditional RAG will simply not fit. Neither the graph RAG will, because of the nature how it slices the information and actually cuts it very specific and kind of creates a network of information, which works, for example, very well in medical field, but less for financial industry. I hope this makes sense.
No, for sure. Thank you so much.
Thanks, David, for asking. Any other technical or non-technical questions you would like to raise? If not, Tatiana, you have?
Hey, hi, yes.
Ciao.
Hello, but I don't think you can see me for
No,
some
but
reason.
we can hear you very well, Tatiana.
Exactly. Yep. Perfect. So if I have more questions and I would like to discuss in more detail this solution, who is the best person to contact?
So you will receive today an email. Please reply, Vlad, myself, depending on the question, will immediately get back to you, Tatiana.
Perfect. Great. Thank you.
Can I now ask a question? If people don't have questions, maybe I can ask the audience. I would love to hear if any of the people on the call had similar challenges and worked on type of solutions to solve those challenges. I really would like to hear any feedback or impressions on that.
Looks like the question was too difficult, Vlad.
I guess no one then, which is good and bad for us, but that's okay.
Well, I can comment a bit. So what I have seen. So I'm with UBS, and what we have seen generally with chatbot is exactly what you mentioned, Vladimir. That they retrieve data, so the search is working well. But then when users would expect an answer which is giving a bit of a more of an opinion. So when you expect from a chatbot to interpret, that's where it starts to struggle a bit. So if this solution really manages to do more and to put together more context, which seems it does, that's great. But
Thanks.
yeah, I think generally, yeah. So that's a fundamental. I think it's a bit of a gap between what people expect from a chatbot and what
Yes.
chatbots are actually delivering now with these standard RAGs.
You made it to the point, Tatian, and that's exactly it's the expectations management. People hear a lot of news, everything is possible, but then they get a chatbot in the organization and it struggles with some more complex questions. That's very much true. And then people start challenging the value of Gen AI in the organization, but actually that's kind of the wrong path. So yeah.
Yeah, thank you.
Thank you.
Maybe I can ask a follow-up question about we're at a very early stage of developing these kinds of agents, and one of the challenges that we've come across is understanding what's going on under the hood, for want of a better word. So, a lot of the time you don't actually understand why an LLM might be making a certain decision. I'm curious, in your development of this, how much did you have to explore that and, try and understand what's happening and the kind of decisions that these LLMs are making? Was that a challenge for you? Is that something that you needed to expose as much as possible?
During the development of those agents, especially with vector search, we had a challenge that with almost every question you would ask, you would get a slightly different answer. Now, depending on how concrete the question or inconcrete the question was, so the inconsistency of answers was one thing that we were fighting with, and what really helped was compressing the content, because that kind of stripped out all the qualitative, let's say, data and just kept the context, and our LLM search could identify the right content much more consistently. There is still, to a certain degree, let's say, a challenge that if I ask what are the strengths and weaknesses of UBS, which is a very subjective question, that I might get slightly different answers each time I asked. And this is good and bad. And again, it comes to expectation management, explaining if I would let 10 people read UBS quarterly report of 100 pages, and I ask what are the strengths and weaknesses of UBS, 10 people will give you 10 different answers. But where I expect consistency is if I ask specific questions like, what is the cost income ratio of UBS investment management? There is no discussion. I really want to see the right number. So again, comes back to what Tatiana said, understanding the challenges of the current technology or the features, and also managing expectations with your clients or with your users. Both are equally important. I don't know if this helped answer your question, David.
No, it did for sure. Certainly helped in how to explain these things to other stakeholders.
Very good. Happy to hear that.
Well, we are just on time. I want to thank you, everybody participating, attending this deep dive session. Thanks, Vlad, Andreas, and Marius for preparing and running it, and also Emilia for supporting us. As I said, if you have further questions or you would like to have some more one-on-one sessions, please reach out. You will receive today or latest tomorrow the email with access to this information and to this recording. And we are looking forward to stay in touch with you and have a wonderful day. Thanks, everybody, for joining.
Thanks, everyone. Thank you,
and your
Nello.
interest.
Thank you all. Bye-bye.
Thanks.
Stay in touch.
Thank you.
Bye.
Bye-bye.
Thank you.